This series of HTFA series has a separate special tester for measuring the characteristics of current transformer, and there is also a voltage transformer and a current transformer integrated with the same type series. That is to say, I can buy the current transformer characteristic tester alone and also can buy the transformer tester. The transformer tester is the voltage transformer and the current transformer. What are the differences? That is to say, there are some differences in the performance of the instrument. This series also has a higher power version. The current of low power version and high power version can reach 1000 A, while the current of low power version can only reach 600 A. So our demonstration operation today is based on the mutual inductance of the HTFA in this series. This paper introduces the characteristics of the tester. Okay, let's talk about the wiring of the HTFA transformer characteristic tester. The current transformer we use is a current transformer, so our instrument is integrated with current and voltage, so we are using a current transformer now. So the operation of our examples today is all based on the current transformer. If the voltage transformer is operated, you should press the voltage. When the transformer is operated, its wiring can be read in the manual or the instrument. Or you may forget that there will be some wiring graphics on the instrument panel. These graphics correspond to your transformer operation, volt-amp operation, or some other operation graphics. Then you can find the corresponding test wiring diagram you want to do and follow this figure. There is no problem in connecting. But I still hope you can read the manual in detail, because after all, this figure only talks about some simple wiring. So some problems about operation that should be paid attention to will be explained in detail in that manual. Then we will start the formal operation. Then we will first take a look at our current mutual inductance. For the CT panel, we have completed the variable ratio polarity test, which is the most basic test. For example, the two thick terminals are marked with P1 and P2, so we use the larger current line in the accessory. Because a larger current will be output from this place, we must use a large current wire, which is connected to me. The first test of the measured transformer. And then the two small terminals are connected to the secondary measurement of the current transformer. We know that the secondary measurement current of the current transformer is very small, so there is no problem to use this kind of thin wire. We must pay attention to it. We recommend customers, and we also hope that customers develop a good operating habit. Then you should connect the wires according to the corresponding colors. At this time, you can connect the wires according to the colors. At least, it will be convenient to determine the polarity you measured. If there are some polarity problems, you will easily reflect whether you are wiring problems or transformer polarity problems. This is convenient for you to determine the test. Let's first take a look at this. What is the transformation ratio of each transformer? This is a current transformer with a ratio of 600 to 5. Then we must first see its nameplate. Okay, we will start the machine first. We first enter a main interface. Here we have a look. This is a black cursor. We can move the cursor by rotating the mouse. The type we are measuring is CT. If we want to measure the voltage transformer, we choose the voltage transformer, and this side is replaced. Let's go back. Test CT. Enter the CT interface, and then see that our current wiring is to measure the change ratio polarity. First of all, we will measure the change ratio polarity. There is something we need to set. Then our time is 600. So here we are. If you want to set it to 600, the second time is 5A. Then we will start. Click a start. We must be clear there is no operation in this, and it will not raise current because there is a wrong operation. Let's show you whether it comes out. Because it has no value, there is a power switch. The switch will control its output. So in the final test, we must turn on the power switch and start the test. Well, take a look. We have now tested 601.1 to 5A, which is actually 600 to 5A. We have already known that its polarity is negative and its polarity is reduced. Then we can print, save, and return. We also have here the variable ratio polarity of CT. It can also do the function of ratio difference and angle difference. We should also set one. The rated time is 600 to 5. When the cursor moves, it must be set correctly. There is an actual load in it. Let's take a look at the actual load of this place. It is 15 volts. In this place, we have set 15 volts according to its requirements. Of course, our transformer here is a protective transformer, not a metered transformer. This is just a reference. Let's click to start and then click to test. The whole result of ratio difference and angle difference has come out. We print and save. We click to return. Then we do the complete wiring operation. Then we are going to the next operation. The next operation is about its volt-amp test process. Then we start to test the volt-amp characteristics of the current transformer. Then we can see from the graph the volt-amp characteristics only need to be connected twice and not once. Then the primary line needs to be disconnected. When our original one is doing the transformation ratio polarity, its two wires are connected to the secondary, so we can more conveniently translate these two wires to the K1 and K2 of the volt-amp characteristics. We still choose a CT project. Then we directly choose the volt-amp characteristics here, and we can see that there is no volt-amp characteristic. In fact, the excitation is the volt-amp characteristic. We just click on the excitation. Look at the rating, which is higher than 5. The second time is 5A. In this place, the highest voltage the instrument can output is less than or equal to the highest voltage it can output. Our power switch is also on. We click Start and then click Test. Our excitation curve appears in this place. There are some data in it. So all things are set strictly in accordance with the graphics and don't connect wrongly. And then the settings must also be set strictly in accordance with the nameplate, because all these settings are designed with some protection. and your wiring also involves some protection.